Dilations. So a dilation is a transformation in which a figure is enlarged. In which a figure is enlarged or reduced with respect to a fixed point, C, called the center of dilation. So we're going to enlarge it or reduce it. You don't really have to worry about the center of dilation too much. It's always the origin. And a scale factor, K, which is the ratio of the lengths of the corresponding sides of the image and the pre-image. Scale factor here is important. It is represented by the letter K. Don't ask me why it's the letter K. I didn't make it up. That's just what they use for it. Probably has to do with Latin or something. Okay. Scale factor is represented by K. It's a ratio that you're either reducing or enlarging something by. So if you're reducing something by a scale factor of 1/2, that literally says you're cutting everything in half, like 1/2. If your scale factor is 3, that means you're enlarging everything 3 times. That's how that works. Your scale factor is a positive number such that K equals, your scale factor is a positive number such that K equals, what we do is we take the image over the pre-image. So we're going to write this in 2 different ways. K equals the image over the pre-image. Or if you look at this shape here, triangle ABC is your original image, right? Or I'm sorry, your pre-image. That's your original shape. Triangle ABC is your pre-image. Then it got enlarged and it became this red triangle, triangle A prime, B prime, C prime. So what we do is we take a measurement from each of those and compare it, okay? So what you would do is take a measurement from this, sorry, brain farting real quick. So you would take a measurement from your first triangle and compare it to the measurement of your second triangle. How it's written a lot is you would take, how it's written is C prime P prime over just CP. Okay, so you would just take a prime measurement over a not prime measurement. Or I guess, well, yeah. So, because C, if this P is your point. So P is your center. Okay, so that's what you're comparing. Sorry, I had deleted something from last year, so I had was confused about something. So you just take a measurement from your center, right? Take your measurements and compare them. Pretty much the point that's important to remember is you take your image over your pre-image, a measurement from your new shape over a measurement from your old shape. And then angle measures are the same. Your angle measures are going to stay the same whether your shape is enlarged or reduced, okay? Any angle measure is not going to change, because if you have a teeny tiny square and a giant square, aren't all the angles still 90 degrees? Yeah, it doesn't matter. Okay. A dilation is an enlargement when the scale factor K is greater than 1. So if your scale factor is more than 1, it is an enlargement. So 2, 3, 4, 5, 6, etc. It is a reduction when K is between 0 and 1, so 1/2, 1/3, 2/3, things like that. And we tend to talk about our scale factors as fractions. If they're not written as fractions, that's okay. We could turn them into fractions, or decimals are fine too. I'll show you in a second. So we're going to find the scale factor of the dilation, then tell whether it is a reduction or an enlargement. So when we do our scale factor, remember, we are going to take the way that I kind of try to remember it is prime over not prime. You take your image over your pre-image. So remember, take something from your image over your pre-image. Or I think of it as prime over not prime. That should not have a prime on it. Prime over not prime. So if you take a look at this picture here, your pre-image is this blue triangle here, and that was turned into this red triangle here, right? So prime over not prime. If you take a look at your prime, isn't that the smaller shape? So shouldn't the smaller number go with it? So that one goes with your 4. So what that means here is you're going to take this smaller measurement and you're going to put it on top. So 4 over your not prime, which is the bigger shape. So the bigger shape should go with the bigger number, which is 12. So you would have 4 over 12. Can you reduce 4 over 12? Yeah, what would it become? Not 3, that'd be 12 over 4. 1/3, right? Yeah. Now, take a look, 1/3. Is 1/3 greater than 1 or between 0 and 1? Between. So doesn't that make it a reduction? And if you take a look, didn't we start off with a larger triangle and end up with a smaller one? So does that make sense with that? Yeah. So then we would also say reduction. Good. All right, now look at B. This is comparing segments. We started off with this little blue segment here, P. It turned into this little red segment here, P prime. So again, for K, we're going to take our prime measurement over our not prime measurement. So here, prime is bigger, right? So bigger segment goes with the bigger number. So on top, what number should I put? 25. Over P, that's a smaller segment, so that goes with the smaller number, which is 10. Then always reduce your fraction if you can. How would you reduce 25 over 10? I'm sorry? Like, yes, if you wanted to make it a mixed number, you could. I would keep it as improper fractions, though. So, like, you could reduce both of these by 5, right? So that would give you 5 over 2, which you're right, is 2.5. I would just recommend keeping it as an improper fraction. Now, 5 over 2, is 5 over 2 greater than 1 or between 0 and 1? Greater than 1. So is this an enlargement or a reduction? Enlargement. Good. Is that P at the top prime? For which one, Gannon? For part B? Yeah, I just put a giant dash there. So this should be P prime over P. All right. So that's with pictures. Sometimes it'll give you pictures. Sometimes it'll give you like a statement. Sometimes it's actually easier when it's a statement, in my opinion, because you don't have to like decode the weird pictures sometimes. So for example 2, it says in a dilation, CP prime equals 30 and CP equals 12, find the scale factor, then tell whether the dilation is an enlargement or a reduction. So we're going to do the same thing here. We're taking our prime over our not prime. So our scale factor is going to be whatever CP prime is over just regular CP. So what's your measurement for CP prime? 30 over not prime, which is 12. Can you reduce 30 over 12? Yeah, reduce them both by 6. So what's 30 divided by 6? 5. What's 12 divided by 6? 2. So 5 over 2. Is that between 0 and 1 or greater than 1? Greater than 1, so enlargement or reduction? Enlargement. And I'd like you guys to try out part B for that one. So find your scale factor, decide whether it is an enlargement or a reduction. All right. For B, Abby, what did you put for your fraction here? Yep, good. You would put 3 over 12. Were you able to reduce that? No? What could maybe go into 3 and 12? 3, yeah. So it should reduce down to 1/4. Always try to reduce it if you can. Not a huge deal, but it just makes it easier than when we're doing some of the next things. So this would be 1/4. So Trey, do you think this would be an enlargement or a reduction? A reduction, good. Any questions on that part? That part should hopefully be pretty easy, yeah? Okay. All right, now we get into our rules here and graphing some of these. Now, what's kind of nice about scale factors, there's just one rule. There's not a bunch of different things you got to do. You got to remember one thing. If point P, any generic point P, like AB, is the preimage, so if you have some point that's your preimage, then its image after a dilation centered at 0, 0, everything we do is going to be centered at 0, 0, with a scale factor of k. So your scale factor is whatever k is. Maybe it's a fraction, maybe it's a whole number, I don't know. P prime is going to become Ka, comma, Kb. What that means, ladies and gentlemen, is you multiply your x and y coordinate by the scale factor. So if you had a point 2, 3, and your scale factor k was 2, you just take that point and you multiply it by 2. So 2, 3 would become 4, 6. That's all you do. Okay. That does mean there will be some multiplying by fractions, but I promise to do the best that I can to not give you anything weird. Like you shouldn't end up with any weird repeating decimals and stuff because that's going to be hard to graph, right? I'm going to try to give you things that are easy to graph. So for example 3, we are going to graph our triangle PQR. So here's our original triangle, PQR, with vertices at 0, 2, 1, 0, and 2, 2. So here's our original triangle. And graph its image after a dilation with a scale factor of 3. What that means is multiply each coordinate by 3. If your scale factor was a half, you would multiply each by a half. If it was 2/3, you would multiply each by 2/3. If your scale factor was 10, you would multiply each one by 10. So for P prime, we need P prime, Q prime, and R prime. We're just going to simply multiply it by 3. So if you have 0, 2, that's going to become 0, 6. If you had 1, 0, that's going to become 3, 0. And if you had 2, 2, multiply that by 3, you're going to get 6, 6. Does that kind of make sense, guys? Now, when you graph this, should your general shape change? No, just its size, right? And is this one going to be a reduction or an enlargement? So you need to make sure your final picture looks the same shape, just a bigger size, right? Because it's an enlargement. That's an easy way to kind of check it. So 0, 6 is up here. That's P prime. 3, 0 is down here. That's Q prime. And R prime is 6, 6. So that's over here. And then connect your points. And is that the same general shape? It's just 3 times as big. Does that somewhat make sense, guys? And then really the rest of it is just us seeing a little bit of variation with how our scale factors could look. So for example, if you look at number 4, use the graph to the right to reduce the triangle. So it's giving you a heads up, this is a reduction with these vertices by a dilation of 50%. Now, 50% is not a fraction, right? That's not the way we've been seeing our scale factors so far. But think of it, if I tell you to reduce something by, or if you have 50% of something, don't you have less than you started with? 50% would be the same as what is a fraction? Half. You're basically cutting the shape in half, right? Are you absolutely allowed to think of it as cutting it in half? Sure. Or if you want, because also too, if you take a look at this and you're like, oh, 50, is it going to make any sense to multiply these coordinates by 50? Isn't that going to be huge? Are you going to be able to fit that on here? There's no way, right? So hopefully logic tells you, okay, I don't want to use 50. I either want to use the fraction or decimal equivalent. Does anyone know how you would write 50% as a decimal? You move it 2 places, it would become 0.5, yep. Yeah. It technically becomes 0.50, right? 0.50, or if you prefer, you can also think of it as just the fraction 1/2, right? It's half of the original size because it's 50% of what it was. I don't care how you think of it. So let's graph our original shape here, right? So let me just clarify, guys. This 50% is kind of easy. If it was 35%, how would you write 35% as a decimal? 0.35. And are you allowed to use a calculator? You just throw that into your calculator, right? I don't expect you to be able to do that in your head necessarily. All right, so let's graph our original. 4, 6 is A. -4, 2 is B. And then C is 2, -6 down here. I'm sorry, I just remembered I didn't pass out rulers. If you'd like one, they're on my desk. Okay. So here's your original triangle. We are going to take each point and basically just chop it in half. So A prime, B prime, and C prime. Half is kind of an easy way to wrap your mind around. Could you do, in your calculator, could you do like 4 times 0.5 if you wanted? Yeah, but could you also just think of it as what's half of 4? What's half of 4? 2. What's half of 6? 3. Right, so A prime is 2, 3. Then do the same thing to B. Can someone tell me what B prime should be? Oh, come on, guys, you can divide by 2. -2, 1. And then what should C prime be? Good, 1, -3. All right, so A prime is 2, 3. So that's there. B prime is -2, 1. And C prime is 1, -3. There it is. Does that look smaller? Same general shape though? Yeah. Okay. Questions about that? Okay. All right. Time are we at? Sorry, I'm just looking to see. I want to do examples 5 and 6, and then we'll take a little break, okay? So examples 5 and 6, and then we'll take a little break. So example 5 says, this are again just more of the same, just different ways to see your scale factor. So what are the coordinates of the image of triangle PQR, given that P is 5, -5, Q is 10, -5, and R is 10, 5, after dilation with a scale factor of 0.4? Do you think 0.4 is a reduction or an enlargement? Definitely a reduction. Does it matter that it's a decimal? No, because can you just plug times 0.4 into your calculator? Definitely. Okay. So make sure you draw your original figure. 5, -5. 10, negative 5, and 10, 5. So it's like a right triangle over here. Oops. And then take a second and multiply each of your coordinates by 0.4, and I'm going to call on people to see what we get. Okay. P was 5, negative 5. Anna, what'd you get for P prime? Good, 2, negative 2. Q was 10, negative 5. Ethan, what did you get for Q prime? Multiply, actually. Yeah, so what you're going to do is, so your scale factor, 0, negative 4, you always take your coordinate points and you multiply it by the scale factor. So if it's written as a fraction, then you just multiply it by the fraction, like a third, right, or a fourth. If it's a decimal, you still just want to multiply it. So you're going to just take your coordinate point 10, negative 5, multiply 10 by 0.4, and multiply negative 5 by 0.4. Sorry, what, Ethan? It is. Does that make more sense now? Okay. But yes, it is 4, comma, negative 2. Okay, so that would be Q prime. And then R prime, Danny, were you able to figure out R prime? Okay, so with this one, we're just multiplying. So you're going to take 10, 5 and multiply it by 0.4. Do you have a calculator by chance? Okay. If not, so what I'll do, Danny, is I'll come back to you for another one, okay? Gannon, do you have R prime ready, Gannon? Okay, what'd you get? I agree with you. 4, 2. So 4, 2, that should go right there. Oops. All right. Guys, are there any questions about this so far? Keep in mind, people at home, that I cannot see your faces, so I do not know what you are doing or if it makes any sense to you at all. Okay, so please ask. I'm happy to answer any questions at all. Okay, there are no stupid questions unless I've already answered that question 5 times like a minute before. That's really the only time, is if I just got done answering it. But other than that, there are no stupid questions, so please ask. The next one we're going to look at, and then we'll take a little break, is number 6. Now for number 6, I give you triangle FGH. Vertices are 3, 6. So 3, 6. 3, negative 3. And 6, 6. Okay. All right. So now, what's a little weird about this scale factor? Anyone notice? It's negative. And on the front, didn't we say that our scale factors aren't negative? Okay. That's because the negative part doesn't actually adjust the size of your shape. What ends up happening is it adjusts the position. What it does, it's actually going to flip your graph upside down. So when you have a negative scale factor, the negative part is just going to take your graph and it's going to flip it around. But don't change your process. Our scale factor is negative 1/3. So we just need to multiply each coordinate by negative 1/3. Okay, that's what we're going to do. You can plug that into your calculator. Something I want you to keep in mind, though, multiplying by a third. Does anyone know what multiplying by a third is the same as? I would not use 0.33. Does anyone know why I would not change it to 0.33 in your calculator? It's going to be a little off. It's going to give you some weird decimals. So multiplying by a third, though, it's a nice fraction, right? A third, there's a 1 on top. It's actually the same as like dividing by -3. So if you have 3 times -1/3, what's 3 divided by 3? 1. It would just be -1. If you are using one of like these TI-30X IISs, there is a fraction option in here. If you look up at the, I wish I could like show you this thing if you're looking at it from home. If you look at the second row, there's a little button that says A and then B/C. Do you guys see it? Second row, third button down. That's actually a fraction button. So if you wanted to plug 1/3 or -1/3 into your calculator, you would hit -1, then your A, B/C button, and then 3, and it does this weird little L thing, like a 1 and then a -1 and then a weird little L. I wish I could show you guys. And then a 3. That just means the fraction 1/3. So you could use that as well. We'll do this one together because the fraction's a little goofy. So F prime, G prime, and H prime. So F prime, you're taking 3 times -1/3. Another way to think about it, you guys remember back in the day when like your teacher would have you put a whole number on top of a 1? Like 3 is the same thing as 3/1. You can also think of it like that. So if you think of it like that, 3 times -1/3 is going to end up being the same as -3/3. And what's -3/3? -1. I'm like really explaining the fraction. Please tell me if I don't have to. Okay, I just know that like people sometimes mess those up. So 6 times -1/3. Way I would think about it, what's a positive times a negative? A negative, and what's 6 divided by 3? 2. So it's just -2. Then go to G. A positive times a negative is a negative. What's 3 divided by 3? 1. So it'd be -1. Then -3 times -1/3. What's a negative times a negative? A positive, and 3 divided by 3 is 1. So G prime would be -1, +1. And then H prime, you got 6. What's a positive times a negative? A negative, and 6 divided by 3 is 2, right? So it'd be -2. And then the other one's just also 6, isn't it? So it would just also be -2. So you'd have, sorry, I don't know why this isn't erasing, but it would be -2, -2. Okay. So -1, -2 is F prime. -1, 1 is G prime. And then H prime is -2, -2. So it's much smaller and flipped upside down. Do we understand that no matter what, we just multiply the scale factor by the points? Okay. People at home, can you see my note screen? Perfect. Okay. You ready, guys? Got our notes out in front of us? All right. So example 7. What would it mean for an object to be dilated with a scale factor of? And then part A, it's asking us what if K was 0? And for part B, it's asking us what if K was 1? For 0, what do we think? Now keep in mind, guys, don't you take each coordinate and you multiply it by its scale factor? Yeah, what's gonna happen to each point? It becomes 0, right? Each point is gonna become 0, 0, so the entire picture would turn into just one single point, 0, 0, which is the origin. So yeah, what would happen is that the object would become a single point, 0, 0, right? Everything would turn in to 0, 0. Good. What if it was 1? Nothing would change. Wouldn't your shape stay exactly the same? If you multiply something by 1, does anything happen to it? Nope. So the object would stay the same. Good. All right. Find the scale factor of the dilation and the missing value. So this time, I'm giving you 2 objects. In this picture, we have a blue and a red triangle. And we have some information missing. It's telling me that this large measurement here is 35, but this measurement here is missing. It wants me to find it. Now, what I'm actually going to do is find it by using the scale factor. The scale factor is going to stay the same throughout an entire picture. So if one side gets, I don't know, enlarged by 3, all the sides get enlarged by 3, right? If one side has a scale factor of 1/3, all the sides are going to have a scale factor of 1/3. So the first thing we're going to do here is find our scale factor. Remember, for your scale factor K, we're going to take our image over our pre-image. So that's prime over not prime. So if you take a look here, in this case, oh, and I realized I forgot a label here. We're going to label this first one, this red triangle is going to, I'm going to call this A prime, and this blue triangle, we'll call it A. So the red triangle is A prime, the blue triangle, or the big triangle, because if you guys don't have the colored version, the big triangle with the 15 on it is A prime, the little triangle with the 9 on it is just A. So what happened is your original shape was the little triangle, right? And it became the big triangle. So if we're going to do image over pre-image, what's a measurement that we can use from our image in our fraction here? 15. Okay, 15. Why would I not use 35? Yeah, number one, it's not part of the picture, but also too, if I use 35, wouldn't I also need to know what x was? It needs to be like the matching parts. Does that kind of make sense? So like if I pick 15, I have to then also pick 9, because aren't those like the same kind of sides on that triangle? So I'm going to do 15 with 9. Can I reduce that? What goes into both 15 and 9? 3. 15 divided by 3 is 5. 9 divided by 3 is 3. So my scale factor is 5/3. Now what I'm going to do is use this scale factor to find my missing measurement here. That's this x. I need to find x. You guys remember cross multiplying back in algebra? That's actually what we're going to do here. There's more than one good way to solve this, but that's what I would recommend. If these sides have a ratio of 5/3, then these also have to have a ratio of 5/3. So what I'm going to do is take my scale factor, that was 5/3 equals, and 5/3, wasn't that the bigger measurement to the smaller measurement? So here, if you look at 35 and x, which one do you think is going to be the bigger measurement? 35. So we would do 5/3 equals 35 to x. How do you cross multiply? Diagonally, right? You grab things that are diagonal from each other. So you would grab like 5 times x, which is 5x. And then you would grab 3 times 35, which is 105. And then you would just divide. And when you divide that, you should get that x equals 21. Does that sort of make sense, guys? Okay. Figure out what your ratio is and then, okay. And then set up a fraction. People at home, any questions on that? We have another example too if you're a little confused. All right, so take a look at B then. So B, we're gonna make the, we're gonna do the same thing. The red one is gonna be A prime and the blue one is gonna be just A. So the bigger shape is A prime, your image. The smaller shape is just gonna be A, which is your pre-image. So remember when we do our scale factor here, we do prime over not prime, right? So prime over not prime. Now this one's a little tricky because isn't it kind of tempting like on the last one to pick 12? But if you pick 12, don't you have to pick n? And we don't know what n is, right? So what could we maybe pick instead? 28 and 14. And again, A prime, isn't that your bigger shape? So pick the bigger measurement, which would be 28. So do 28 over 14. And how can you reduce 28 over 14? Divide, yeah. 28 divided by 14 is just 2. Or 2 over 1, right? Does that mean the same thing, guys? Yeah. You might like using 2 over 1 because you have to set up a proportion. So either way you want to think about it. All right, now let's solve our proportion. So when we set this up, we're going to take our scale factor, which is 2 or 2 over 1, equals, and then our other sides, which would be 12 over n. Now I have a question for you. When you do this, would it be okay if I did 28 over 14 equals 12 over n? Instead of 2 over 1, would it be okay if I used 28 over 14? It actually would be. Is it going to give you bigger numbers? Yes, but then you will divide. You'll end up getting the same thing because isn't 28 over 14 the same thing as 2 over 1? One's just reduced. Just a heads up in case you decide to do that. It works as well. So then cross multiply 2 times n is 2n. 1 times 12 is 12 and divide to get 6. Okay. I think there's a few on your homework of those for you to practice. And then last thing, right? Last thing? Yes. Last thing. Similarity transformations. A similarity transformation is a dilation or a combination of transformations and dilations. Now, when it says a similarity transformation, similarity is a word we'll talk about actually a lot in this class. When things are similar, they're the same shape, but not necessarily the same size. Okay? So they're similar. They have like some stuff in common, but not everything. So when you do a similarity transformation, that means you're moving things around and your first shape might be a slightly different size than your next shape, but the general like look of it stays the same. Basically, these are just like more combinations of different transformations, right? Maybe you dilate and then rotate and then reflect. Or like in this first one, we're going to reflect and then dilate. And the next one, you're going to rotate and then dilate. So this is just practicing those multi-step ones a little bit more. And I'm gonna, for your activity that you do tomorrow, I'm gonna kind of try to have it set up so it should be similar to your test, so you guys can practice like how to plug those in. I don't know if I'll put any dilations on it because Gold Day hasn't done dilations, so I don't want them to like be totally thrown off. I might like put like deciding if it's an enlargement or not, just basic stuff. Okay, so our first triangle here is F, which is 1, 2. G is 4, 4. And H is 2, 0. It says to now reflect this in the x-axis. So you'll see here, there's a reflection. So when you do your assignment or when you do your quizzes, is it going to be important to look up your old rules? Do I expect you to have them memorized? No. Do I expect you to be able to flip through a packet and find them? Yes. Andrew, did you find the rule for the reflection in the x-axis? It is. It's A, negative B. So we're going to apply that rule to find F prime, G prime, and H prime. So remember, that means leave A the same, make B the opposite sign. So F prime would become 1, negative 2. Somebody I haven't heard from yet today, what would G prime become? Abby. Good, 4, negative 4. Someone else, what would H prime become? People at home are welcome to participate as well. You are in class as well. I know it doesn't always feel like that. What would H prime become? 0. Yeah, it just stays 2, 0. Can't really make a 0 negative, right? All right, let's graph it. Let's make sure it still looks good. So 1, negative 2, 4, negative 4, and 2, 0. That stayed. So there was F prime, H prime, and G prime. And does that look like a nice reflection over the x-axis? Yeah, checking it or graphing it is just a really good way to check your work as you go. All right, now let's look at our dilation. So we're going to find F double prime, G double prime, and H double prime. So our scale factor is 1.5. What do you got to do with your scale factor? What's our rule? What's our little strategy here? Very good. Multiply each number by 1.5. Each of our new points, right? So this one you're going to have some decimals, but they'll be nice decimals. So for F double prime, we're going to take 1 times 1.5. That's just going to give me 1.5. And then negative 2 times 1.5 is going to give me negative 3. And feel free to plug that into your calculator if you need to. G double prime, you're going to take 4 times 1.5, and that's going to give you 6. Negative 4 times 1.5 will give you negative 6. And then 2, 0, 2 times 1.5 will give you 3, and 0 times anything is just 0. So F double prime is 1.5 comma 3, or 1.5 comma negative 3. So 1.5 negative 3 is down here. 6 negative 6 and 3 0. So it got a little bit bigger, right? So there's F double prime, G double prime, and H double prime. Should look something like that. I would like you guys to try out number 10. All right. First thing here was a rotation 180 degrees about the origin. Someone at home that I have not heard from yet today, what is your rule for a 180 degree rotation? Negative A, negative B. All right, so let's apply that to C. So C was negative 2, 2. So Danny, I'm coming back to you now. If C was negative 2, 2, and I apply the rule opposite of A, opposite of B, what should C prime be? You there still, Danny? Danny may have abandoned us. Hannah, what do you think? What would C prime be? Good. C prime would be 2, negative 2. And then Jeff, what about D prime? You there, Jeff? Jeff's not sure if he's here. Madison, what do you think? What would I get if I applied the rule opposite of A, opposite of B to 2, 2? Good. I'll just show you guys the final points here. I lost track of time a little bit. -2, -2, and then for double prime, your final points there should have been 1, -1, and -1, -1. I did. That's okay, Jeff. Yeah, you're fine. Okay, so this should have been your final answer was -1, -1. I'm sorry, 1, -1, and -1, -2. Sorry, guys, lost track of time today. Have a lovely day. Don't forget, tomorrow is your e-learning day, okay? And we will be just doing extra practice with this. Have a lovely day. Sorry? No, I will be checking the homework for you guys the next Maroon Day, which is Thursday. Yep.